Hi guys, I often use Wago connectors and have always wanted to learn how they heat up under different conditions. Today I will be testing the Wago 2214. The rated current is 32 amps and the permissible continuous operating temperature is 105 degrees Celsius. In this test, I aim to determine the maximum temperatures Wago and wire will reach at prolonged currents of 20, 25, 32 and 40 amps. It's also interesting to check if two random Wagos will have the same internal temperature and find out which side of the terminal heats up more. Front or back. The test circuit is connected to the terminals of the output number 3. Two Wagos are connected in series with 2.5 mm squared wire. The left Wago is positioned with its front side. The right Wago is positioned with its back side visible, showing the contact plate. Temperature sensors are connected inside each terminal. The left temperature meter and the right temperature meter. The temperature meter number 1 measures the temperature of the wire that connects two Wagos. Additionally, I will use a thermal imager to measure the external temperatures of the connectors as well as the wire. So, let's start testing. Starting the first test at 20 amps. Initially, let's take a look at the temperature meters. Temperatures are almost identical across all points. This is likely because the current isn't significant enough to cause noticeable heating. Let's check the thermal imager. We can see that the highest temperature is on the wire and on the Wago, which is turned with its back side. It's 2 degrees higher than the Wago with the front side. Returning to the temperature sensors, we observe that the internal temperature is 42–43 degrees Celsius, while the wire is around 40 degrees. The temperature has stabilized. We'll wrap up the test now, and I'll show the graph for a few seconds. The second test is 25 amps. At 230 volts it would be more than 5 kilowatts. We can see that the heating is happening faster. In the thermal camera image, the difference in external temperatures of connectors is already about 4 degrees. The temperature of the wire insulation is approximately the same as that on the right Wago. On the temperature meters, we see that the temperatures inside the Wagos are almost the same and a few degrees higher than the wire temperature. After 4 minutes, the temperatures inside the terminals exceeded 50 degrees. Let's continue. So, at 25 amps, the internal temperature exceeded 53 degrees. The third test will be at 32 amps. This is the rated current for this Wago. It should handle it. I see quite intense heating. In the thermal imager, it's clearly visible that the right Wago heats up much faster than the left one. At the same time, the internal temperatures are equal. It can be concluded that the backside heats up faster and more intensely. After 2 minutes, the temperatures inside Wagos are almost 60 degrees, and the temperature difference between the external sides is about 5 degrees. After 5 minutes, the temperatures increase slowly. And I see that at 32 amps, all elements of the test circuit are performing well. Their temperatures are between 60 and 75 degrees. The last test will be at 40 amps. This is overcurrent for both the Wago and the 2.5 mm squared wire. The heating is very fast. After 1 minute, the maximum temperatures have already exceeded 55 degrees. After 2 minutes, 75 degrees. 80 degrees. The temperature of the connecting wire has exceeded 70 degrees, but the Wago temperature is within the acceptable limits. I remind you that the allowable continuous temperature for its plastic is 105 degrees. And will internal temperature reach 100 degrees? Unbelievable. Even inside, it's less than 100 degrees. Great result. I analyzed all the graphs and would like to share my thoughts on 32 amp testing. So, the maximum temperature of the plastic was observed on the right Wago and reached 62.7 degrees. Even at 40 amps, it was about 85.2 degrees. This indicates that the terminals have a decent safety margin. However, it's important to note that all the tests were conducted in the air at the temperature of 25 degrees Celsius. These are easier conditions since the test circuit has natural cooling. In the next video, I will conduct tests in a closed electrical box. The maximum wire temperature in this test was 61.1 degrees. The second conclusion is that each test clearly shows that the back side of the Wago heats up faster and more intensely. Here, the difference of the temperatures was about 5 degrees. This is because the back surface directly touches the contact plate. The higher the current, the greater the difference of the temperatures. It makes sense to measure temperatures specifically on the back side. What do you think? And one more thing, I liked that the internal temperatures of random Wagos were almost identical. Of course, testing just 2 connectors doesn't rule out the possibility of manufacturing defects, but at least it provides some statistics. Thanks for watching, write your comments. Don't forget to like video and subscribe to follow the ElectroTest channel. See you soon.